Hi, welcome to this en masse prediction for the OCR Paper 5 Higher Tier Maths GCSE November 2020. Enjoy! Hi, welcome to this Paper 2 prediction from onmaths.com. If you haven't done the Paper 1, then you won't know that you can go and this link here, and it will take you straight through to onmaths.com where you can try this paper out completely for free, and you can even sign up for free. It will save your scores and all that stuff. You can do that before you even watch this video, or what some people do is they like just to watch the video, understand how to do the questions, and then test themselves afterwards. So what is the prediction? Well, prediction basically is our estimation of what comes up every single time with this exam board, what hasn't come up in ages and is long overdue to come up, and it's basically a guess. And it's an educated guess, but it is a guess, and that's why I say in every video, don't just do this and rely on it 100%. There will be a lot of topics that come up in this paper, but there also will be new topics that don't come up. So make sure you do all your revision, whether that's with onmaths.com or mathseffect.co.uk or a different website or a different revision guide or whatever it is. Make sure you do the work first. Otherwise, let's get started. Okay, so this question's about an adult and two children. So we've got David Smith and two children. So there's one adult and two children. But the prices shown are not quite right because there's a discount. There's a fifth off adult price and 30% off the child price. So let's work out the adult price first. So a fifth off. Well, first of all, let's work out a fifth of £70. So to work out a fifth, you can just divide 70 by 5. Now I know that 10 fives are 50 and 4 fives are 20, so that's going to be 14. So that's going to be £14 he gets off, so therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70. And then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So it's 900. That's 21 with a 0. So 900 plus 21, 210 even, 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 is 27, take away 1 is 26, take away 10 is £25.90. Now that's for one child, so that's one child. So if I want two children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80. So that's going to be £51.80. Okay, I'll move down a bit. And let's do the total. So the total is going to be the adult price, which is this one here, plus the two children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished.
When you're asked to describe the relationship between two things on a scatter graph, the sentence you need to write is, as this one increases, this one either increases or decreases. So as time of day increases, test marks, and because they're going up, it's a positive correlation, test marks increase. So there's a difference between describing the type of correlation or writing the type of correlation and describing the relationship. When you're describing the relationship, it's just as the one at the bottom increases, the one up the side either increases or decreases. So it says, using the scatter graph, the examination centre then conclude that time of day leads to positive effect on test scores. Are they correct to make this conclusion? Basically, this is a question about the fact that just because two things correlate does not mean that one causes the other. So a sentence like, there may be other factors such as, I don't know, what else? Tiredness, fatigue, tiredness. So try and make sure you give an example as well to support your argument.
Question A seems like a really complicated question, but it really isn't. If you think about what you know about a rectangle, you know that opposite sides of a rectangle are equal. So if you just write down x plus 1 is the same as 12, and then solve it. So what we're going to do is we're going to take away 1 both sides. Then x equals 11. So we know that x is 11. Let's check that out. It says here x minus 1. Well, what is 11 take away 1? Well, it's 10. And that is the same as that. So we know that x equals 11. And that's it. Question B. Have a think about what you know. You know that all angles in a triangle add up to 180. So we know that if we add y, 2y, and 3y together, it's going to equal 180 degrees. So again, let's just get our lines down so that we can solve it. So 1y plus 2y plus 3y, well, that gives us 6y in total. And then what we need to do is get rid of that times 6 there by dividing 6 both sides. So y equals 180 divided by 6. Well, I know 18 divided by 6 is 3, so I know that's going to be 30. Okay, for Venn diagrams, it's really important to understand the notation. This symbol here means union. It just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B. It needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. So to answer this question, we need to be really familiar with the formula y equals mx plus c. Now y and x will constantly change, but m is what we call the gradient, and c, or plus c, is what we call the y-intercept. Okay, so we need to understand how to use that formula for this question. Now it already tells us that the gradient of the line is 3, so we can fill that in. So it's y equals 3x plus c. Nice and easy. The only thing we don't have is the y-intercept. Now the way of getting the y-intercept is substituting in the values we know. We know when x is 3, y is 17. So what I'm going to do is just put in the values. Put in the values of 3 for x and 17 for y. So it's going to be 17 equals 3 times 3 plus c. And I'm going to put my lines in so that I can solve it. So that's 17 equals 9 plus c. And we're going to take away 9 from both sides. So it's going to be 8 equals c, or just c equals 8. So looking back at this formula we had earlier, we had m but we didn't have c. Well, we now have c, which is 8. So it's y equals 3x plus 8. And you can check that by putting in the values of 3 as x and see whether you get 17. 3 times 3 is 9. 9 plus 8 is 17. Okay, so we've got quite a lot going on with this question. We've got 3 planks of wood attached by glues and nails, or glue and nails, so we don't need to worry about the joins. But we're looking at the 3 planks of wood. Now, we've got 2 of the lengths. One is 6 meters and the other's 8 meters. But we need to find, obviously, the third length here to be able to continue with this question. So, given the fact it's a right angle triangle, and we know 2 of the length, and we're finding a third length, it's going to be Pythagoras. And Pythagoras says that a squared plus b squared equals c squared. Now c is the one that has to be the hypotenuse, and to find the hypotenuse we just go opposite the right angle. So we're finding c. A and b don't matter which way around we do it, so I'm going to do 6 squared plus 8 squared equals c squared. And I can put my lines down as I normally do. So I always put the lines down that equals. I've just missed that one. So 6 squared is 36, 8 squared is 64, which equals c squared. 36 plus 64 is 100, equals c squared. What I'm going to do is just square root both sides, so c will equal 10. Now when you square root you get a negative as well, but since it's a length it can't be negative, so it's just going to be 10. So c is 10, so we know that that's going to be 10 meters. And it says it takes 90 millilitres of paint per metre of wood to cover it. So what we're going to have to do is work out how much wood we have. So I'm going to say to the examiner wood length or something. Always try and describe to the examiner what you're doing. So we're going to do 6 plus 8 plus 10. So 6 plus 8 is 14 plus 10 is 24. Okay. And then to work out the amount of paint required, so paint required, I need to do 24 because we've got 24 meters of paint times 90 because it's 90 milliliters per meter.
So we can do this with the grid or column method. Doesn't really matter which one. I'll do the column, why not? So 0 for the first one, and then we're going to do 90 times 4, so we need to add a 0. 9 times 4 is 36. 9 times 2 is 18, plus the 3 is 21. And what we could have done is 9 times 24 and just added a 0 onto the end of it. There's loads of different ways of doing these things. So it would be 2,160 millilitres. If you ask this in litres it would be 2.160 litres, because there's 1,000 millilitres in a litre. Okay, these are simultaneous equations, and I'm just going to write these out again so I've got a bit more space. So equals 63 and 2x minus 6y equals 0. Okay, so the important thing with simultaneous equations is that you need to either get the coefficient, the number before, the x, or the coefficient of the y the same. Now in this one we already have the coefficient of the y being the same. They're both 6. Yes, one's a positive, one's a negative, but we don't worry about that. And with simultaneous equations we work downwards, which was step 2, but in this one, because the question has been nice, it's going to be step 1. Now we look at the signs for the one with the coefficient that's the same. So the y's have a 6 before it, so we're looking at these signs here. Now if they are the same sign, we subtract. If they are different signs, we add. And it's that simple. Now they are different signs, so we know we are going to add. So we're going to add going downwards. Okay, so 5x plus 2x is 7x, and we're going downwards. 6y plus minus, well the minus wins a plus minus, so 6y minus 6y is 0, and it has to be 0, otherwise we can't answer this question. And 63 plus 0 is just 63. Then we put our lines in to solve it. So 7x equals 63, divide both sides by 7. So we have x equals 9. Okay, now next we're going to pick one of these equations to substitute that 9 into. I'm going to pick the first one, but I could probably easier to pick the second one, doesn't matter. So I'm just going to rewrite this first equation. But instead of 5x, we know it's 5 times 9 plus 6y equals 63. I'm going to put my lines in, and we've got to find out what y is now. So 5 times 9 is 45 plus 6y equals 63. And then what we're going to do is we're going to take away 45 from both sides. So we're going to do 63 take away 45, which is 18. So 6y equals 18. And then we're going to divide by 6 both sides, so y equals 3. And what you can do if you've got some time is just put it into the second equation. So we're going to do 2 times 9, which is 18, and 6 times 3, which is also 18. So 18 take away 18 is 0. So the answer is x equals 9 and y equals 3. Okay, so this is quite a complicated question because there's two ratios and they're talking about slightly different things. We're also given an amount of one of the sides of the ratio, or one of the sides of one of the ratios, and we're asked for the amount of the first side of the ratio. So it's all a little bit complicated, but the way I'd like to start these things off is by just writing down what I know from the question. So we've got football, rugby, and we've got tennis. So football to rugby is 4 to 3, and rugby to tennis is 6 to 13. So these two ratios here are kind of incompatible at the moment. Got this one here, which is linking the football and the rugby, and we've got this one here, which is linking the rugby and the tennis. What I'd like to be able to do is kind of like put the two together and make just one ratio. So if you notice from the one I've put around a blue square or blue rectangle around, we've got the rugby as 3 parts of that, but in the green one, the rugby is 6 parts of that. So what if I times both of these by 2? If I times both of them by 2, I get 8 to 6, and that actually matches the other ratio. So what I can then do, because it's the same parts of rugby, I can then say that it's 13 parts tennis. Okay, so all I'm interested in here is matching these two up to make these both the same. So I times the one in blue by 2 and it made it exactly the same. Now it says that 39 students picked tennis, so I need to find some way of getting the tennis to be 39. Well, that's going to be just simply timesing it by 3. And if I times that one by 3, I've got to times this one by 3, and I've got to times this one by 3. So 6 times 3 will be 18. And 8 times 3 will be 24. So we've already answered the question, because if there's 39 tennis, there's going to be 24 football. This is not the easiest question, or ratio question out there, but if you just try and link the two ratios together, then it will start to make sense and it will start to become a lot easier.
Right, whenever you're asked to estimate, basically what that means, it normally is round everything in the question to one significant figure and then work it out. Now there are a few exceptions to that. For instance, if you're asked root 82, the easiest thing to estimate that to is root 81, not root 80, because you know what root 81 is. Root 81 obviously is 9. But mostly it's one significant figure. So we're going to go through everything in the question and just round it to one significant figure. Now, 64, for 64, the line goes after the first digit for significant figures. That 6 will stay as a 6 because that 4 is less than 5, and that 4 will just turn to a 0. For 160, the line will go between the 1 and the 6. That 1 will round up to a 2 because the next number is 5 or more, and the other numbers will turn to 0. 22 at the bottom, line goes down there, that rounds to 20. 98, line goes down there, the 9 will go up to a 10, and the 8 will turn into a 0. So that question turns into 60 times 200 over 20 times 100. Now there's different ways of doing this. We can multiply them out. So 6 times 2 is 12 with 3 zeros. 2 times 1 is 2 with 3 zeros. And then we can just cross off the zeros. So 1, 2, 3. And then we're left with 12 divided by 2, which is going to be 6. And when I say cross off the zeros, what I'm doing is dividing top and by 10, and then by 10 again, and then by 10 again. So the answer is 6. There are different ways of doing it. I could have cancelled down at this stage here and divided top and by 20, as that would leave 10 there. And then divide top and by 10, so that would leave 10 there. 60 divided by 10 is going to be 6. Loads of different ways of doing it. Okay, first thing to realise with this question is how you calculate the mean. The mean is the sum of all the values over the amount of the values. Now this actually creates a triangle, just like speed, distance, time triangle. Works in the same way. So we have mean here, we have the sum at the top, and the amount at the bottom. So we normally do the sum divided by the amount, but actually with this question we need to go the other way. And we need to work out the sum or the amount or whatever. Let's have a look. So it says there's 12 boys and 8 girls. So in total there's 20 children. So that's the first thing we need to realise. It says the mean number of coins for the children is 15, and the mean number of coins for the boys is 13. And we've got to work out the mean number of coins for the girls. So we know how many girls there are, which is 8, but we don't know the total amount of coins for the girls. For the boys. Okay, so where do we start? Well, it would be helpful to work out how much coins there are in total. So if I look at the triangle there,
we know, so let's write down total children. And try and show my working out as I go. We know that the mean of all the children is 15. So in my triangle, I've got 15 for the mean. We know that there are 20 children in total, and we can work out the sum by timesing those together. So we're going to do 15 times 20. So there's 300 coins altogether. Okay, so now next we're going to work out, well, we're given the boys, so let's work out how many the boys have. So same triangle. We know the mean for the boys is 13, and we know that there are 12 boys. So we're going to do 13 times 12, which is 156. So to work out how many girls there are, or to work out the sum of the girls, we're going to do the sum of all the children, which is 300, take away the sum of the boys, which is 156. So we'll do 300 take away 156, which is 144. So we know what the girls add up to, because if the boys add up to 156 and the total children adds up to 300, then the girls must add up to 144. But we're asked for the mean for the girls. So to work out the mean, we just go back to our standard formula we had at the start, which is this one. To work out the mean, it's the sum, which we worked out as 144, over the total, and it says there's 8 girls. So we do 144 divided by 8, which equals 18. So our answer is 18. Okay, this is quite a lengthy question, and again, it's one of those questions, there's multiple ways of doing it, so if you've got a technique that works really well, stick with it. But with this question, and with any fraction questions, you need to make them top heavy first. So that's what I'm going to do with both of these fractions. So 6 1/3. And to make it top heavy, you times by the bottom, and then that answer you add to the top, and then you keep the bottom the same. So 6 times 3 is 18, add to the top is 19, but keep the bottom the same, so it's still over 3. So 4 1/2, we times by the bottom, which would be 8, and then add it to the top, which would be 9. So that equals 9 over 2. So we're going to do 19 over 3 times 9 over 2. So I've written the same thing, 6 1/3 times 4 1/2, but instead of 6 1/3, I've written 19 over 3. Instead of 4 1/2, I've written 9 over 2. Okay, so one thing you can do at this step, which will help us write it in its simplest form, is you can divide anything at the top and anything at the bottom by a number to simplify it. So the 9 at the top and the 3 at the bottom, I can divide them both by 3. So that will leave 3 at the top there, and it will leave 1 at the bottom there. Now, this is really important because if I times these across, I would get a really big number. Now, I'm still going to get a big number, but it's a lot smaller and a lot easier to spot how to simplify at this stage. Okay, and some people call this the bow tie method, because if I draw a nice bow tie over it, it can be any number at the top and any number at the bottom. So it can be down here, or diagonally across, hence the bow tie method. So now instead of doing 19 times 9, I'm doing 19 times 3, and you can do any method you want. I mean, some of you would do 20 times 3 and take away 3, but let's do a little grid. 19 times 3, 30, 3 times 9 is 27, so 30 plus 27 is going to be 57. And now we're doing 1 times 2, which is 2. Now, it says that it wants it as a mixed number, so we need to do that now. So 57 over 2, we need to make that mixed number. So we've got to work out how many 2's there are in 57. Well, I know that 56 divided by 2 is going to be 25 plus 3 is 28. So there's 28 whole ones and 1 remainder. So what you do is you work out how many 2's there are in 57, which is 28, and then any left over, any remainders at the top, just create the fraction. So the answer is 28.5. Okay, so in this question, you might think that to get the answer to this, you do 40 divided by 5 to get to 8, so you divide that by 5 and you get one machine. The problem is that doesn't make any sense. If 5 machines take 40 minutes, that's almost an hour to make one toy, then what, one machine's going to do it in 8 minutes? It just doesn't make sense. And a question like this that doesn't make sense, if one increases, the other increases, is an inverse proportion question. Now there's an advanced way of doing it where you work out the formula and you do it that way. I'm going to show you a slightly different way that's maybe easier for some people. So if you think about the machines, which is one variable, and the time, which is the other, and we've got 5 machines and it takes 40 minutes, then if we times those together, we get something which I'm going to name machine time. Okay, I've just made that up. So 5 times 40 is 200. Now that 200 there is really special because that 200 must always be the same. The machine time must always be the same. So it says we want to do it in 8 minutes. So I've got to think, right, what times 8 is 200, because machine time will always be the same. So I get my calculator and I'm going to do 200 divided by 8, and it's 25. So let's check that. 25 times 8 is 200, so it works. Now that is the answer, that we would take 25 machines. Let's just check if it makes sense. So 5 machines take ages, they take 40 minutes to make a toy, yet 25 machines take only 8 minutes to make a toy, so that makes sense. You'll notice that we've divided that by 5, but we've times this one by 5, and that's the way inverse proportion works. As you divide one of them, you times the other. Okay, there are 2 things you need to know, main things you need to know about kind of advanced number indices. And the first one is that anything to the power of 0 is not 0, but it is 1. And the reason being is, say we had 10 squared divided by 10 squared, that would be, take away the powers, so that would be 10 to the power of 0, because when you divide you take away the powers, but any number divided by itself is 1. So therefore anything to the power of 0 is 1. The second thing you need to remember is if you have a negative power, all you do is you get the number, it's 3 to the power of 1, which is just 3, and put a 1 over it. So if you had 2 to the power of minus 2, that would be 1 over 2 squared, or a quarter. So the negative just results in putting a 1 over it. Now if you have a fraction, and we do it to the power of a negative, you actually just flip the fraction. And that's it. That's called finding the reciprocal. So there we go. If you ask to find the reciprocal of something, you just put a 1 over it if it's an integer, if it's a whole number, or just flip it if it's a fraction. The easiest way of approaching this question is to understand what multipliers are. Multipliers, you always start off with 100%. You work out what's happening, so let's say we're adding 40%. And then you work out the final percentage, which is 140%. The final thing you do is just convert it to a decimal. So divide by 100 to make it 1.4. That means you can multiply any number by 1.4 and it will go up by 40%. So in this question it says we have Billy, we have James, and we have Sam. And we're told that James collects 40% more sand than Billy, so he's got 40% more. We're told that Sam collects 20% more sand than James, so he's got 20% more. By what percentage has Sam got greater than Billy? Okay, now the obvious answer is 60, and if you write 60, unfortunately you're not going to get the right answer. The way of doing this, as I said, is to understand
multipliers. So we imagine Billy starts off with 100% and he's gone up by 40%. So that means he's now got, or James has 140% of what Billy has. Now, as a multiplier, that's going to be 1.4. So whatever amount Billy has, we're going to times that by 1.4 to get James's amount. Then, James then has the 100%. We add 20% on to work out what Sam has, which is 120% of what James has. As a multiplier, that's going to be 1.2. So we're going to times James's amount by 1.2 to work out Sam's amount. Now the problem is we don't know what the amount is, but we do know what we're going to do to it. We're going to times 1.4, then times 1.2. So if we get our calculator, or if it's on a non-calculator paper, then you have to do this the long way. And I type in 1.4 times 1.2. And that will tell me in total what I'm timesing Billy's by to get straight to Sam's. Like so. The answer to that is 1.68. Now that's as a decimal. If I convert that back into a percentage, that means Sam, if Billy has 100%, that means Sam has 168%. So therefore, Sam has 68% more than Billy. Now, if you're adamant the answer is 60, you need to go through this, because this is why this is such a high topic, is understanding that actually it's not going to be. And the government, with all their statistics, all the time use this, and people think, oh, it's 60%. It's not. It's 68% for this question. Okay, so whenever we're asked to find an inequality or draw an inequality onto a graph, always draw the line but without the inequality in it. So instead of x is greater than or equal to 5, always draw the line x equals 5. If it can be equal to it, it's a solid line. If it can't be equal to it, it's a dashed line. Okay, so it's x equals 5, and I'm going to draw a solid line. So where does x equal 5? Well, x equals 5 here, and here, and here. And in fact, anywhere along that line, it's just a vertical line up, and that's the line x equals 5. And it's really important to remember which way around it is. Whenever you have x equals something, it's always a line from top to bottom. When you have y equals something, it's always a line from left to right. Okay, that's the line x equals 5, but it asks us to mark the region in the inequality with an R. So it's either going to be to the left or the right of this line. Well, it says that x can be anything that's greater than or equal to 5. So x could be 5, 6, 7, 8 on this graph, okay, because obviously it only goes up to 8. So anywhere this side of the line is absolutely fine, so I'm going to mark my R there. And actually sometimes the exams ask you to shade it in, so I just shade in that right hand side of the graph. Sometimes you shade in what you don't want, and if I was shading in what I didn't want, obviously it would be on the left hand side of that graph. So this question asks us to factorise, and this is a kind of special type of quadratic. Basically, one way of thinking about this is we've got an x squared plus 0x minus 121. So we need to find two numbers that multiply together to make minus 121 and add together to make nothing. Now the only way you can get two numbers that add together to make 0 is if they're exactly the same number but one's positive and one's negative. So we know that they're going to have to be the same number. So when I put in my two brackets, because it's a quadratic, and I put an x at the start of each, we know they're going to have to be the same number. Now 121 is not a number that's just been made up. It's always going to be a square number, otherwise this doesn't work. And one of them will need to be positive and one of them will need to be negative. Now if you expand that, you will find out that you've got 11x plus minus 11x, which cancels the x's out, which is why in the question there's no x terms. It's called difference of two squares if you wanted to look it up to revise it.
And these look like quite difficult questions. I'm just going to enlarge it a little bit. But this is just a matter of remembering a set of rules. And the rules are simply whatever number at the bottom here means the root that you're looking for. And this is just the normal power. You start off with the root. So because it's a 2, it's going to be a square root. If it was a 3, you'd find the cube root. So we're going to find the square root of 16, which is 4. And we leave that power there, so it'd be 4 to the power of 3. And 4 to the power of 3 is 64. So the number at the bottom is the root, the number at the top is just a normal power. Always do the root first. There's another rule here, so it'd be minus 2/3. So like before, that's going to be the root. This 2 is going to be the power. And this minus here just means to find the reciprocal. And that's it. That's just a matter of memory. So there's nothing about a negative in the power that would make you think that you'd find the reciprocal of it. And there's nothing to do with the fact that the bottom is 3 would mean it's going to be a cube root. It's just a matter of practicing it and remembering it. So we're going to deal with the reciprocal first. And to deal with the reciprocal, all we need to do is put a 1 over it. So it'd be 125. We've got rid of that negative now, so it's just 2/3. So it's 125 to the power of 2/3, but all of that is with a 1 above it. If it was a fraction, so if it was a fraction in brackets, we would flip the fraction, but if it's not a fraction, we just put a 1 over it. Next we're going to deal with that cube root. So the cube root of 125 is going to be 5, and we haven't dealt with that 2 yet, so we're going to leave that there. And that 2 is just a normal power, so it'd be 1 over 5 squared, which is 1 over 25.
This question could be a show that question where it gives you the decimal and the fraction, or it could just ask you to work it out. So it could turn up on either paper. So the first thing I'm going to do is just convert this. I'm just going to be investigating this first, and then I'll worry about the 0.0 later on. Okay, so way of doing this is get x equal to 0.8686 blah 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 recurring. Now we need to bring that 86 in front of the decimal point, so I'm going to times it by 100. So I'm going to work out 100x is 86.8686 blah blah blah. And then what you do is you just take away going downwards. The reason we do that you will see in a second. So 99x, because it's 100x take away x, which is 99x, and it's 86 point recurring pattern, take away 0 point recurring pattern. The recurring patterns take away, so we're just left with 86. I'm then going to divide both sides by 99. So it's x equals 86 over 99. Now, I said I'd ignore the 0.0 bit. I'd ignore this bit earlier. Well, I can't ignore it anymore. So how do I get from 0.86 recurring to 0.086 recurring? Well, I'm just going to divide by 10. So what I want to do is I want to do 86 over 99 divided by 10. Now the way I can do that is just times the bottom of the fraction by 10, and that's the same as dividing it by 10. And we should write 0.086 recurring equals, to show the examiner that that's what we're doing. Okay, so we can cancel at this point. If you have a look, we can divide top and bottom by 2. So we're left with, I can show that I'm dividing by 2. So we're keeping the fraction the same. So that will be 43 over, and half of 900 is 450, half of 90 is 45, so it would be 450 plus 45. And you don't need to show this working out, but I'm doing it just to show you. So it'd be 495. Now, I don't think there's another number that goes into 43 and 495, so I'm going to sort of leave it there. Normally when you're asked to simplify, or normally when the numbers are big, you won't be asked to simplify it, or there will be a very easy way of simplifying it. Okay, so there's a couple of formulas we need to remember with this. We need to know the trigonometric area formula, and that is the area is half a b sine c. A and b are the lengths either side of the angle, and c is the angle. And the other one we need to know is just normal triangle, half base times height. And it's a right angle triangle, so we've got the height and we've got the base there. Okay, so it says in the question that the areas are equal. So we're going to work out the area of A, we're going to work out the area of B, and we're going to get them equal to each other. It's that simple. So to work out the area of A, we use our trigonometric area formula. So that's half AB. A is x and B is x, so that's going to be x squared, sine the angle, which is 30. And the other formula for the other triangle is going to be half times 1, well anything times 1 is just itself, times the height. Now whenever you've got an expression, always put it in brackets. So I'll put this in brackets. Okay, cool, right. We're going to tidy this up a little bit before we start solving it. I'll need longer lines than that, so I'll just draw these down a little bit longer. Okay, you need to know that sine 30 is a half, okay, and that's a requirement for the exam. So you need to know that that is just going to be a half without a calculator. We've got loads of videos on exact values that you need to know, and I think there's 8 of them you need to know. I probably got that wrong. But anyway, so we're going to expand the bracket. So half x plus, and our half of 3 is going to be 1.5. Am I sure? Yeah, that's right. Okay, cool. Okay, next thing we're going to do is, looking at that, I'm just going to times everything by 2. I'm just going to times everything by 2. And you've got to times everything by 2, so don't just do it once, both sides. You've got to times everything by 2, and actually that's part of the same term. So anything that's anything that's separated by plus or a minus, you've got to times by 2. Okay, so here we have x squared times a half equals x plus 3. Cool, right, okay, so next we're going to we're going to times everything by 2 again, actually. Should times everything by 4. Get rid of the half. So we've got 2x plus 6. Okay, now looking at the requirement in the question, it says it wants it in the form a plus minus root b. Now that hints at the fact that we are going to complete the square to solve this. It means that basically we can't work out the exact answer, but we can show it as a square root. You could also use the quadratic formula. I'm not going to do that. I'm going to do completing the square. To complete the square, you need the x terms on the same side. So actually, I'm just going to write down what I'm doing. Get ahead of myself. I'm going to take away 2x from both sides. I'm going to extend my line even more. And so we've got x squared minus 2x equals 6. Now to do this, what we need to do is we need to put a set of brackets down, and it's going to be x, and it's going to be half of the number before the x. So if you have a look here, it's a 2 there, so we're going to subtract 1 inside the bracket, and we're going to square it. Okay, there's loads of videos on completing the square, so if you don't know how to do that, just check out the video. Just type in on maths completing the square. We've also got an erroneous 1 that generates, which we don't want, so we need to take away the 1 on the outside, equals 6. Next we're just going to add that 1 to both sides, really simple. So we've got x minus 1 squared equals 7. Extend my lines even more. We're nearly done though. We're going to square root both sides, so it's going to be x minus 1 equals root 7, and then we're just going to add 1 to both sides. So x equals 1 plus or minus root 7. Now the reason that plus minus is there is when you square root a number you get a positive and a negative answer. So our answer is a will be 1 and b will be 7. Okay, so box plot question. Now, it might be tempting to think that the information here is all you need to plot on the box plot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other two that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is at 22. There we go, and that's our box plot. So that's question 1 done. Or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students. So I just need to find out 25% of 140. And I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. And so we're going halfway there. Now we can't really say 17.5. That doesn't make much sense. So on this question, I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. It doesn't actually matter which one you write down, because you've shown that it's 17.5, well, you can't get half a student, so let's go for 17, or let's go for 18.
Okay, so this is an inverse proportion question. So the first bit I start with for this question is this line here. So as soon as I see that, I just write down B, and this fish symbol, which means is proportional to. The inverse is 1 over, so whenever it says inversely proportional or varies inversely, it's 1 over, and it says the square of A, so I'm just going to write A squared. Now I'm going to get my lines in. Okay, so to get that fish sign to an equal sign, I need to times the right hand side by K, so it becomes K over A squared. Now I'm going to pick a value of A and B. Now A and B are called variables, they're going to change. The K though is a constant. When we find K once, we found K for good. Now looking at these options, I kind of like this one the best. It's kind of simple. I like a nice simple fraction, 1/8 and 8. Okay, I can work with that. So it says B is 1/8, so I'm going to substitute in B is 1/8. And K we are trying to find out, and it says A squared, so it would be 8 squared, which would be 64. So I'm going to times both sides by 64, so I can find what K is. So it becomes 64 over 8 equals K, so therefore K is equal to 64 divided by 8, which is just 8. So putting that back into this equation here, or formula here, becomes this equation here. So B equals 8 over A squared. Okay, I'm going to use that to find out what A is when B is 2. So I'm going to write the same thing as I've written down for my answer here, but instead of B I'm just going to write 2. So 2 equals 8 over A squared. Get my lines down. Okay, so the first thing I'm going to do is times both sides by A squared. So the best thing to do is get rid of any brackets or fractions, and since that means divide, over means divide by a squared, and times by a squared, so it would be 2a squared equals 8. Then I'm going to divide by 2 both sides, so I get the a squared in its own, so it's a squared equals 8 divided by 2 is 4. Then I'm going to square root both sides. So this could be 2 or minus 2, but it does say positive value, so a equals 2. So if I put a as 2 into the answer to question A, it would be 8 over 2 squared, which is 4, so 8 over 4, which is 2, so b equals 2.
Okay, so in this question we're given 5 times square root 125, and we're asked to make it in the form 5 to the power of something. So this bit here is kind of our objective. We've got to make this so it's just a single power of 5. Well, 5 at the moment, well, that's quite nice of them to give us a 5, but 5 is to the power of 1, and that's going to be maybe important later on. So 5 to the power of 1 is just 5 times. Now, I notice 125 is actually 5 cubed, so I'm going to rewrite that as 5 cubed. 5 times 5 is 25, times 5 is 125, so that might help us. I'm thinking, right, that square root I can rewrite as to the power of a half. So I'm going to get that 5 to the power of 3, and I'm going to put that to the power of a half. To the power of a half and square root are the same thing, and that's something you need to know about indices. Okay, now the second rule that I'll need is if I've got a number inside and a number outside of a bracket, which I do here, I times them. So that's going to be the same as 5 to the power of 1.5, or 3 over 2. Okay, or 1.5, I could just write it as 1.5, it doesn't matter. Okay, it's sometimes easier to do just a top-heavy fraction, because obviously when you're writing powers you're already writing small, and it gets a bit complicated otherwise, so it doesn't matter. And the other rule I'll need to know about indices is when you times them you add the powers. So it's going to be 5 to the power of 2.5, and it says write your answer as a decimal, so it's 2.5 as a decimal is just 2.5. Now there are two things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side it's just the same numerator but without the denominator. Now I said there were two things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x. And the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side, and all of the other terms, so the x terms, the number terms, or whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y, and on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3, so we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here, it could be 5x plus 10, that's absolutely fine, still the right answer, over x plus 3. The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this, because you might be taught it in a slightly different way. But if you were to draw a triangle for us, frequency density and class width were at the bottom and frequency at the top. Now it's a little bit misleading because actually this is proportional to the frequency density, so it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these, because I'll need to know what they are. So the first class width, we're at 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10, and the last one's 15. So when I've got the class width, I can work out the frequency density. And the frequency density is the frequency according to the triangle divided by the class width. I want to divide these. Okay, so we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2. So can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. So that would be perfect. So I can go up in ones on the 5 squares. So it would be 0.2 here because they're 2 squares. 0.4, 0.6, 0.8, 1.0 or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high and it's 0 to 10. So we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20 and it's 0.1. So it'll be down here. I'm not going to get these exact, but with your one it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one because it's only one square across. Let's try and get it as close as I can. So that's 1.2, but it's only 1 square across. Okay, next one, 25 to 35 is 0.3. So that would be there. And last one is 35 to 50 and 0.4. So we go up one and then we finish that off. Excellent. Okay, so the next question says work out an estimate for the number of trees greater than 40 meters. So I want to draw a line up from 40 and we want it to go across here. So we're looking for an estimate for the amount that are in here. if you look at it, I've shaded in 2/3 of that last group. In the last group there are 6, so I want to find 2/3 of 6, because the total frequency for that bar is 6, and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4. Okay, here we're asked to simplify an algebraic fraction, and whenever you've got quadratics in an algebraic fraction and you're asked to simplify it, always factorise them. Now, this is pretty complicated because this is two quadratic equations where a, which is the coefficient of the x squared, is greater than 1. But it just takes longer. It's not really more difficult, just more stuff to it. So we go times these together, which is 60. Well, technically minus 60. And we need two numbers that add together to make the minus 11 here. So I think they're going to have to be. You're probably going to have quite a big negative number, and quite a small positive number. So thinking about it, probably minus 15 and 4. So 15 times 4 is 60. Therefore, minus 15 times 4 is minus 60. And minus 15 brings us all the way back to minus 15, and then add 4 moves us back to minus 11, so that works well. Okay, next step to do is we rewrite the quadratic, but instead of minus 11x, we're going to write minus 15x plus 4x, which is the minus 15 and the 4 we had, minus 20. If you don't understand any of this, please look at our videos on factorising quadratics, which goes into this a little bit more detail. Okay, so we're going to divide out the 3x here, so we're left with x minus 5, and we're going to divide out the 4, so that would be 4 brackets x minus 5, and then we put the repeating bracket and the leftover pieces together. So we've got 3x plus 4, and then we've got the repeating bracket there. Okay, one down, one to go. So the next thing we need to do is do exactly the same thing again. Oh, the wrong one. Exactly the same thing again here. So that'll make 110. Now, we need two numbers that times together to make 110, add together to make minus 21. So we know both of the numbers will be negative. And to be honest, when they use numbers as high as 110, chances are it's just going to be 10 and something. So this will be minus 11 and minus 10. They try not to be too mean with it. You'll never get any of the numbers that are higher than 12, probably higher than 10, unless there's an easy second number. So if it's like 15 and 2, or for example 15 and 4 we had before. Okay, so we rewrite this one. But instead of that minus 21x, we do minus 11x minus 10x plus 55. So same as before, we're going to factorise these and factorise these separately. So we're going to divide out the x here. I don't think there's anything else, no. So 2x minus 11. Now we're going to have the minus here, and I think there's a 5 we can get rid of. So 5. And then 2x. Now be careful with this bit. To get that plus 55 when we expand the bracket, this needs to be negative here, and that's a common gotcha for people, but we know that this must be a repeating bracket, so that can help us out sometimes. We can look at the repeating bracket and go, oh hang on, it needs to be a minus for that bracket to be repeating. So x minus 10, and then put the repeating bracket. Wow, okay, right, so I'm going to rewrite this fraction here, but this time with its factorised versions. So we've got bracket 3x plus 4, x minus 5 at the top, and at the bottom we've got x minus 5, 2x minus 11. Okay, now we're going to cross out the repeating bracket at the top and bottom. So we're going to divide top and bottom by x minus 5. So that gets rid of that and gets rid of that. So we're left with 3x plus 4 and 2x minus 11. Now these questions are really good to be practicing factorising quadratics, because you get 2 for the price of 1 with these ones. But for your answer, you don't need to put the brackets because there's only those expressions at the top and only that expression at the bottom. But if you can go through these, also a little bit of a hint is because when you're simplifying algebraic fractions, I mean, you'll pretty much always get a bracket in the top and bottom to simplify at the end, to cross out at the end. Otherwise, you can't simplify it. So if you've done the top, you can actually cheat a little bit and work out, the fact that the bracket at the bottom will either be 3x plus 4 or x minus 5, and that can help speed things up. You can also check your answer, because if you don't have a repeating bracket at the top and bottom, then you've probably done something wrong. Okay, so this doesn't seem like the easiest questions, because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple, because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x, because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x, because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder. Wow. Tell my maths teacher. Right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed. Brilliant. So plus the cone. Now, what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'm going to put my lines down. Okay, so what have we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100, and let's do the pi next, pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. There's both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100, we can divide them both by 2, equals x over 50. So our answer is h equals x over 50. Okay, so a circle theorem question. With these questions, it's really important that you set all your working out and you give reasons for every step. So I'm going to do it one way, and there probably are slightly different ways of doing it. And as long as you give the reason, then that's absolutely fine. We're asked to find ODF, and just to help us, I'm just going to mark that on. So it's that angle there. Now, just finding this angle here, which we're going to start off with, it doesn't mean that it's the same angle as that. You can't guarantee that the arrow is going to be symmetrical. So we're going to start off with this one. But how do I show the examiner that's the one I'm starting off with? Well, the letters are there so you can actually write down what you're trying to find. So I'm looking for angle OBC, and you could write the word angle or angle OBC, or you can just do a little angle on top of the B. And we know that that's going to be 90 take away 51, and the reason is that angle between tangent and radius is 90 degrees, and that's one of the circle theorems. So AC is a tangent, and OB, because O is the centre, is a radius. So the whole thing's going to be 90. So when I do that, so I'm going to do 90 take away 51, which is 39 degrees. So we know that that's 39 degrees. And it's absolutely okay to mark it on the diagram as well. And actually sometimes, not often, but sometimes the examiner will look at the diagram and might give you some extra marks because you didn't show the working out. But most of the marks for these types of questions are for the reasons, and you can't really show reasons on the diagram in a way that the examiner is going to be able to see it. So I also know, let's have a look what else I can work out. Well, that's also 90 degrees, and that's also 90 degrees. And ADOB is a quadrilateral. So we can work out which angle we're going to pick next. Well, let's pick this angle here next. So what's that? DOB. So angle DOB is going to equal 360 take away 30 plus 90 plus 90. Okay, so I need to give a reason. Well, let's work it out first, and we can give a reason afterwards. So we're going to take away, 880 plus 30, so that's 210 from 360. That's going to be 150 degrees. And the reason is angles in quadrilateral. And we should really say that the angle ABO and ADO are angles between a tangent and radius as well, but I'm not going to. We've already used that reason, and it's clear in our diagram that we've just repeated the same reason. Okay, so angle DOB we've got as 150. Let's mark that on our diagram. So we can work out this angle here. Okay. And it's very difficult to know what to call this angle because we've already called DOB once. So we could call this other DOB. Let's go for that. Other DOB equals 360 minus 150. Okay, and the reason for that is just angles on a point. So that's 210 degrees, angles on a point. Okay, so what are we up to next? Well, we can work out this angle here, and actually let's mark on the 210 as well. So we've got it all on our diagram. We can work out angle DFB. So DFB, and this time we're using the circle theorem that says angle at the centre, which is the 150. Is twice the angle at the circumference. So angle at the centre is twice the angle at the circumference, so it's going to be 150 divided by 2, which is 75 degrees. So angle at centre twice angle at circumference. Now, if your teacher's given you different ways of writing the circle theorems down, that's absolutely fine. There is no strict way of writing it down. So that's going to be 75 degrees. And if you look, we've got the arrowhead BFDO, which is a quadrilateral, and we've got 3 of the lengths. So we can work out ODF. I'm going to have to scroll up because my memory is not that good. So we're going to take them all away from 360. And what is it? 210, 75 and 39. Okay, so we're just going to take those away from 360. And obviously if you're doing this in the calculator paper, then please feel free to use a calculator. And we get 36 degrees. And again, it's just angles in quadrilateral. As a rule of thumb, my experience with these questions is they're normally looking for between 2 and 3 reasons. Obviously on this question there's an awful lot of reasons, but if you walk out of the exam and you just think, oh hang on, I only wrote down 3 and actually there's a 4th, sometimes you'll get the full marks, so don't panic too much. Just when you're doing the question, try and write down as many reasons as you can. Even really obvious ones like angles on a straight line or angles in a quadrilateral will help you get the marks. Normally, again, for circle theorem ones, they're looking for circle theorems as well as those ones.
Okay, so with this question we need to understand how graphs are influenced by changes in the function. Anything happening within the bracket is to do with the kind of x direction, the left to right. Anything outside the bracket is normally to do with, or is to do with, up and down, so the y direction. So here we've got a +1, which means it's going to shift either left or right. So when we're adding or subtracting within the bracket, it's going to move left or right, and the whole function, the whole equation, the whole graph will move to the left or right. The weird thing about inside the brackets is it goes kind of the opposite way to what you'd think. You'd think a +1 would move 1 to the right, and that is absolutely not the case. It is for when it's outside the bracket. So if it's add 1 outside the bracket, you'd think it would move up 1, which it does. That's normal. But it always does the opposite of what you think inside the bracket. So a +1 will actually move it 1 place to the left. So it will actually subtract 1 from each of the x-coordinates. So we need to find a few x-coordinates, so that one there looks good. So that one there will now shift 1 to the right here. The turning point at the bottom will shift 1 to the right, and we've got 0, 3 there, so the y-intercept will shift 1 to the left. And I think we've got one up here, I think we've got one up here. Now, it's notoriously difficult to draw graphs on this, but I'm going to try my best. I think it's going to be easier for you guys. I would advise you to turn your page 90 degrees clockwise for this. It's always easier to draw a C rather than a U. That's just a piece of advice. I mean, you do what you feel is best. And I'm going to try my best here. We need a nice little bend at the bottom there. Okay, so I didn't do too badly. I think I missed that penultimate coordinate there, the second to last one. But just try and remember you want to move 1 to the left if it's a +1. If it said -1, you move 1 to the right. Okay, so this question seems really easy at first, but there's a bit of a gotcha in it. So the first thing I'm going to do is just calculate, oh, click the wrong one. I'm just going to calculate the total length of this line here, because I think that will help me for later on. So that's going to be 35 centimeters, and the other one will be x plus 7, so that's not going to be helpful writing that down. Okay, so we've got two similar triangles, which means one's a direct enlargement of the other one. And so this seems quite a simple task relatively. So that 5 there grows to 35. Okay, and to do that we do, well, to work out the scale factor, so scale factor, so the 5 to the 35. The scale factor is going to be 35 divided by 5, which is 7. So scale factor is 7. So therefore this one here, to go to the larger length, which I can highlight, and just kind of, there's blue here. We're going to times that also by 7. So if this times is by 7, then this one will times by 7. So that will be 49. So x plus 7, the whole length would be 49. So to find x, it's just going to be 7 less than that. So it's just going to be 42. So x is definitely looking like it's 42. However, it does say there's two possible solutions. One of the flaws that we've made is that we've assumed that the 5 corresponds with the 35. That this length here corresponds with the total length here. However, that's an assumption that we've made because it kind of looks like it does. And we're kind of used to questions where it does, because normally we know that these two here are parallel and therefore it definitely would. But there's nothing in the question that says these two are parallel. So it could be that this 7 centimeters here is the one that corresponds with the 35 centimeters here. So we've got to then run the figures again. So it could be that the 7 corresponds with the 35 centimeters. So scale factor then would be 35 divided by 7, which is 5. So if the scale factor is 5, then we're going to look at this top one here, the 5 centimeters here, and times that by 5 to get to the x plus 7. So it'd be x plus 7 equals 5 times 5, which is 25. And then take away the 7 both sides, which would be 18. It's very, very difficult to get your head around that, because it's so convincing that these two lines are parallel, but they're definitely not. And the hint in the question, in this one anyway, is that it's saying that the diagram is not drawn accurately. And in the exam, if they ask a question like this, you'll notice that the two lines here are going to be subtly different sort of slants on them, so that it's not too misleading. But yeah, very, very difficult to spot, and sometimes in the exam you'll have questions like that. You just need to try and think through what assumptions have you made, and are you right to make those assumptions.
This question might just ask you to rationalise the denominator. It might ask this question in the form that it's in, or it might ask you to show that that fraction is the same as another one, where you'll get marks for the working out. So to do this one, what rationalising means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalising means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top. So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want, first outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. And root 5 times minus root 5, well, a positive times a negative is a negative, and any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5 is going to be, well, if you think about it, you've got 11 of something and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those, so that becomes 25, that becomes 3, and that becomes 58. Now, the 3 doesn't go into 25, so we can't cancel it any further. So it's going to be 25 for A. B is the coefficient of the root, so it's going to be 3, and the bottom number is 58.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website on maths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on onmaths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, and you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the Maths GCSE as a journey, and you go through each topic, mastering it one topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's been caught up in this terrible situation, which is not ideal for anyone, but equally, like, we all understand why it's happened. But if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open, or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.